World War II is remembered as a conflict of tanks, bombers, and codes, but few realize that one of the most decisive forces was invisible. The war over Europe was fought not only on land and in the air, but also in the atmosphere. Every flight, every convoy, every offensive depended on the winds, the clouds, and the storms. Whoever could predict them more accurately held an advantage as great as superior weapons. By September 1939, when the war began, meteorology was no longer a theoretical science, it was a weapon of strategy. Germany possessed some of the finest weather schools in Europe and a dense network of observation posts stretching from Scandinavia to the Atlantic. The Allies quickly understood that without precise weather intelligence, their armies and fleets would move blind. Thus began an invisible conflict, a struggle for the skies and the data within them. This was a war without bullets or bombs. Its weapons were thermometers, radios, and barometers. Its soldiers were meteorologists, radio operators, intelligence officers, and polar explorers. Though their names rarely appeared in headlines, the fate of entire campaigns depended on them. The first skirmishes of this hidden war took place in the north. The Arctic, with its storms and icy winds, was the key to all weather over Europe. The air masses borne over Greenland and Iceland moved south toward the British Isles and the continent. Whoever controlled the Arctic could foresee when the skies would clear for bombers or when a storm would stop a fleet. In 1940, Germany began constructing secret weather stations across occupied territories and even on remote islands of the Arctic Ocean. Teams of Wehrmacht meteorologists, disguised as scientific expeditions, established bases on Spitsbergen, in Greenland, and along the northern coast of Norway. Their task was to transmit coded weather reports to the Reich every 6 hours. Those reports guided Luftwaffe raids and U-boat operations across the Atlantic. The Allies soon realized they were losing the upper hand. Their own network of weather stations, scattered across the British Isles and Iceland, was too limited to monitor the entire northern zone. Forecasts often relied on guesswork. Convoys sailed into storms, air missions were delayed, and landing operations were canceled because of unpredictable weather. In response, British intelligence, working with the Royal Navy and the Meteorological Office, launched a secret initiative known as Weather Watch. Its mission was to intercept German transmissions and build a parallel system of observation, including mobile ship-based outposts and reconnaissance aircraft. By 1941, the British began dropping automatic weather stations onto Arctic ice, each powered by batteries and designed to transmit pressure and temperature data in real time. These devices became vital and dangerous assets in the secret war for weather. The Atlantic soon became a battlefield of radio waves. The air was filled with encrypted messages carrying temperature readings, wind speeds, and coded coordinates. German submarines sometimes deployed fake transmitters to mislead Allied meteorologists. Allied pilots reported strange metallic structures on the ice. Disguised as wreckage in reality, they were German automatic weather stations dropped by U-boats. Meteorological charts became classified military documents. In both London and Berlin, weather reports were guarded with the same secrecy as troop movements. Meteorologists worked beside cryptographers, translating the sky into numbers and symbols that could decide victory or defeat. A single incorrect assumption could cost thousands of lives. By 1942, both sides understood that victory in the air and at sea depended on who could predict storms and fog more precisely. Germany relied on its continental stations and Arctic bases. The Allies' on-air reconnaissance, naval observers, and neutral weather sharing agreements. Hidden observation posts were established in Norway, Iceland, and even Ireland under the cover of scientific research. One of the most critical aspects of this secret war was the data on high-altitude winds. These upper air currents determined the flight paths of bombers and the success of strategic missions. A miscalculation of just a few degrees could send entire squadrons off course. At Allied headquarters, Meteorologists were no longer just scientists. They were called the men who controlled the sky. By late 1943, the weather war had become vast and complex. Both sides formed specialized meteorological intelligence units stationed in remote, perilous regions in the Arctic, across the North Atlantic, and on isolated airfields in Iceland. The people who recorded pressure, humidity, and wind direction risked their lives as much as frontline soldiers. Their daily task appeared mundane, yet the precision of their readings shaped the fate of nations. Few outside military headquarters understood that above the European front raged another kind of conflict, a war for the forecast, a war for wind and cloud. And soon, this invisible war would determine the success or failure of one of the most important operations in human history. By 1944, the struggle for control of the skies had turned into one of the most secret and decisive fronts of the war. The Allies were preparing for the largest amphibious invasion in history, the landing in Normandy. Every decision, every hour, and every life would depend on a factor no general could command: the weather. For months, meteorologists in London, Belfast, and Reykjavik worked around the clock. Their task was to read the invisible movements of the atmosphere above the North Atlantic, a vast, chaotic system of winds, clouds, and pressure fronts that dictated Europe's weather. They gathered radio signals from ships, aircraft, and Arctic outposts. Each line of data, temperature, pressure, wind speed, was a piece of the puzzle that could determine the fate of the invasion. On the other side, in occupied France and Norway, German meteorological teams were doing the same. Their forecasts came from networks of stations stretching from the Bay of Biscay to the northern fjords, as well as from secret bases in Greenland. Both sides knew that whoever understood the coming storms would hold the true advantage, because weather could make or break an entire operation. The Germans had a powerful asset. Their Arctic weather stations provided advance readings of Atlantic storm systems before they reached Europe. These stations, often installed by U-boats, transmitted valuable early data to the Luftwaffe and the Kriegsmarine. The Allies, in turn, relied on convoys and aircraft flying from Newfoundland and Iceland, but these sources were few, often interrupted by German patrols, and dangerously vulnerable to attack. By early 1944, the Allies had begun to close the gap. British codebreakers at Bletchley Park intercepted and decoded many of the German weather reports sent from the Arctic. This allowed Allied meteorologists to map both enemy data and their own, creating the most comprehensive atmospheric picture ever assembled during the war. But even with superior intelligence, the challenge remained the same: predicting what the Atlantic would do next. The invasion of Normandy, Operation Overlord, required calm seas, low wind, and clear skies for the bombers and paratroopers. Yet in June 1944, a vast storm front was forming over the Atlantic. German forecasters, deprived of data after several Arctic stations were destroyed, believed the bad weather would last for weeks. The Allies knew more, but even they could not be certain. In a small room west of London, 3 men, meteorologists from Britain, the United States, and Canada, studied maps spread across a long wooden table. Lines of pressure twisted like veins across the paper, showing systems that could either bless or doom the invasion. For days they watched the shifting patterns, comparing barometric drops, analyzing wind speeds, searching for a window, a brief gap in the storm when the sea might calm and the clouds might part. That window came unexpectedly. On June 4, a small Allied weather ship stationed far out in the Atlantic recorded a subtle rise in air pressure, a sign that the storm was about to weaken. The data was transmitted to London and confirmed by reports from Iceland. It was the signal everyone had been waiting for. After a tense night of calculations, the lead meteorologist, Group Captain James Stagg, presented his forecast to the Allied Supreme Commander, General Eisenhower. The message was clear. A brief period of improved weather would arrive on the morning of June 6. After that, the storm would return, possibly lasting for weeks. Eisenhower faced the most critical decision of the war. The invasion was already postponed once due to bad weather. Thousands of ships and aircraft waited, engines idling, soldiers ready but restless. If the operation failed because of a storm, the consequences would be catastrophic. If they waited too long, the Germans would discover their plans. The forecast held. Eisenhower gave the order to proceed. On the 6th of June, 1944, under clearing skies and calmer winds, the Allied Armada began to cross the Channel. The storm eased just long enough for the landings to succeed. By the time the weather worsened again, the beachheads were secure. Unbeknownst to the Germans, their own meteorologists had predicted continued bad weather. Convinced that no invasion could occur under such conditions, many officers, including Field Marshal Rommel, were away from their posts. The misjudgment of a single weather system changed the course of the war. After D-Day, Allied meteorological units became indispensable. Specialized weather squadrons flew daily reconnaissance missions, mapping the skies over Europe. Balloons measured upper air winds, and ships in the North Atlantic reported real-time conditions. The success of Overlord elevated meteorology from a support science to a core element of military planning. Meanwhile, German efforts collapsed. Their Arctic stations, once their most valuable assets, were destroyed or captured. In some cases, their crews were stranded for months before being rescued. The loss of accurate weather data crippled German air operations and submarine campaigns. The weather war was not just about forecasts. It was a battle of endurance, of science and secrecy. Men froze on remote ice fields and risked death at sea, not for glory, but for a few lines of data that could shift history. When the skies cleared over Normandy, few soldiers landing on the beaches realized that a handful of weather readings, gathered thousands of miles away, had opened the gates to Europe. It was a victory not only of arms, but of atmosphere, the triumph of those who learned to read the wind. After the success of D-Day, the importance of weather forecasting reached new heights. The Allied commanders had witnessed how a few hours of clear skies could decide the fate of a continent. From that point on, control of meteorological intelligence became as vital as control of the seas or airspace. The secret weather war entered its most sophisticated and far-reaching stage. The North Atlantic remained the battlefield of the invisible struggle. The Allies now dominated the ocean's surface with fleets and convoys, but the atmosphere above it was still unpredictable. Storms rolled in from the Arctic, thick fogs blanketed shipping lanes, and powerful jet streams, still poorly understood at the time, carried bombers off course. The war's outcome still depended on who could understand and predict the skies faster. By late 1944, the Allies had built a global network of weather observation points, stretching from Newfoundland and the Azores to Iceland and northern Scotland. Hundreds of ships served as floating weather stations, transmitting constant updates on barometric pressure and wind direction. High-altitude reconnaissance aircraft, equipped with new sensors, began daily missions over the Atlantic and continental Europe. Each flight carried meteorologists who risked enemy fire and extreme turbulence to measure the air itself. Meanwhile, the remnants of the German Meteorological Service tried to keep up. Their once dominant Arctic network was collapsing. U-boats that had previously supplied weather teams were hunted relentlessly by Allied anti-submarine patrols. Radio transmissions were intercepted and jammed. Many German outposts, isolated and low on supplies, were forced to abandon their instruments and destroy their equipment before capture. The weather had turned against them literally and strategically. In late 1944, as the Allies pushed deeper into occupied Europe, weather forecasting began to influence bombing operations on a daily basis. Before every major air raid, meteorological officers in London and Paris analyzed hundreds of reports from across the hemisphere. The success of bombing campaigns over Germany depended on knowing where clouds would part and where the winds would carry the planes. It was during this time that meteorologists began identifying new atmospheric phenomena, powerful currents of air moving high above the Earth, later known as jet streams. Allied pilots reported encountering extreme tailwinds and headwinds at high altitude, often changing their flight times by hours. These discoveries, though still poorly documented, hinted at a deeper understanding of the global weather system knowledge that would later transform aviation and meteorology alike. In Germany, desperation led to secrecy. The Luftwaffe established temporary weather stations hidden in forests and on mountaintops. Some were mobile units, constantly changing location to avoid Allied reconnaissance. They transmitted in short bursts to reduce detection, sending coded data on humidity, visibility, and cloud cover. But their reports grew increasingly unreliable. The lack of Arctic data, combined with frequent Allied jamming, left German forecasts incomplete. Their bombers often flew blind into storms, while Allied squadrons, guided by superior intelligence, took advantage of clear air corridors. The weather war had become one-sided. One of the final acts of this invisible conflict unfolded in the winter of 1944-1945 during the Battle of the Bulge, as German forces launched a surprise counteroffensive through the Ardennes. Heavy fog and snow grounded Allied aircraft, giving the enemy temporary advantage. But Allied meteorologists, monitoring pressure systems from the Atlantic, detected that the weather would soon clear. When it did, the skies opened for Allied bombers and fighters, reversing the course of the battle. Once again, the forecast had changed the outcome. In the final months of the war, meteorological intelligence became part of every level of planning, from naval escorts in the North Sea to strategic air raids on Germany. A network of thousands of observers, pilots, and scientists worked silently behind the scenes. They analyzed wind charts, recalibrated barometers, and decoded radio signals. Their tools were fragile and their data uncertain, yet their influence was immense. As Allied armies advanced into Norway and northern Germany in early 1945, they discovered the remains of several German weather stations. Some were manned by skeletal crews who had survived for years in isolation, sending daily reports into the void. Others were automated devices, buried in snow, still transmitting faint signals. To the scientists who found them, these relics were evidence of a forgotten front, a silent war fought not with weapons, but with observation and mathematics. When Germany finally surrendered in May 1945, the last mists of secrecy around the weather war began to lift. In London, meteorological officers compiled vast archives of wartime data. Millions of observations covering 6 years of storms, winds, and atmospheric pressure. These records would later form the foundation of modern weather forecasting. The war for the skies had changed science itself. Out of necessity, humans had mapped the invisible. The Allied triumph in meteorology had not only supported victory, it had revolutionized humanity's understanding of the Earth's atmosphere. Yet, for the men and women who fought this hidden battle, there were no medals or parades. Their success remained locked in archives, overshadowed by more visible victories. But those who knew understood a simple truth. Without them, the great operations of World War II, from D-Day to the final bombing raids, would never have been possible. They were the soldiers of the wind, guardians of the forecast, and their silent war had reshaped history. When the guns finally fell silent in 1945, the world entered an age of reconstruction. Cities lay in ruins, economies were shattered, and the scars of the conflict were everywhere. Yet above the devastation, the skies remained vast, silent, and filled with knowledge gathered through years of war. The secret battle for weather, waged in shadows and radio waves, had left behind something remarkable, a completely new understanding of the planet's atmosphere. For the first time in history, humans had measured the Earth on a global scale. From the Arctic to the tropics, thousands of stations, ships, and aircraft had collected data on pressure, humidity, and temperature. What began as a military necessity evolved into one of the greatest scientific legacies of the 20th century. The Allies quickly recognized the value of this vast meteorological archive. In London and Washington, teams of scientists worked through stacks of reports, decoding the atmospheric story of the war. The data covered 6 years of continuous observation storms, winds, cloud formations, and pressure fronts mapped across half the globe. For meteorology, it was an unprecedented treasure. Germany, too, had made its contributions. Captured archives from the Reich's meteorological services included meticulous logs from Arctic and Atlantic stations. Though born from war, these records became the foundation for peacetime cooperation. In the years that followed, former enemies would share the very information they once fought to protect. The post-war period saw the birth of a new kind of warfare, one fought not for land, but for knowledge. Meteorology, once a tool of secrecy, became a symbol of unity. The newly formed World Meteorological Organization, established under the United Nations, used wartime techniques to create the first truly global weather network. Nations that had once been adversaries now exchanged data daily. Yet beneath this cooperation lay the memory of the conflict. Many of the techniques that powered modern forecasting, high-altitude balloons, radar, and atmospheric modeling were born from the desperate needs of the Second World War. The Allied effort to predict the weather for D-Day had forced scientists to think on planetary scales. Now, that mindset continued into peace. In the early Cold War years, meteorology took on new significance. Both the United States and the Soviet Union understood that control of the upper atmosphere could provide strategic advantage. The knowledge gained from wartime weather studies helped design new aircraft, missiles, and communication systems. Once again, the sky became a frontier, not for bombs, but for technology. But the men and women who had fought the secret weather war rarely spoke about their role. Many returned to universities and observatories, resuming quiet scientific lives. A few stayed within military meteorological units, helping to build early warning systems for aviation and defense. For them, the war had proven that forecasting could save not just lives, but nations. In the decades that followed, historians began uncovering the hidden chapters of this invisible struggle. Declassified documents revealed the extent of the operations, the Arctic expeditions, the coded transmissions, the lives lost on frozen islands for a single set of readings. In Germany, stories emerged of isolated weather teams that had continued transmitting long after surrender, unaware that the war was over. In Britain and the United States, the meteorologists of D-Day were finally recognized for their role in one of history's most consequential decisions. The deeper scientists studied the wartime archives, the more they realized how much the conflict had advanced meteorology. New methods of upper air observation, the discovery of jet streams, and the invention of long-range forecasting models all traced their origins to those turbulent years. The idea that weather could be predicted across continents was no longer fantasy, it was a legacy of war. Even decades later, the story of the weather war still astonishes. It was a conflict fought without armies, in silence, where success depended on precision, patience, and understanding forces beyond human control. It was a reminder that the fate of nations can hinge not only on courage or strength, but on knowledge, on the invisible science of the air. Today, satellites orbit the Earth, transmitting real-time weather data every second. Forecasts cover weeks instead of days. Storms are tracked from space long before they reach land. Yet all of this began with the desperate wartime need to read the sky, to understand where the wind would blow and when the clouds would break. The men and women who served in the secret weather war did not see themselves as heroes. They were scientists, engineers, and sailors, armed not with weapons, but with instruments. They measured the unseen, reported the unthinkable, and changed history without ever firing a shot. Their legacy is in every modern forecast, every satellite image, every storm warning. It is in the silent collaboration of nations that once fought for the same winds. The secret weather war over Europe ended long ago, but its echoes remain in every prediction of rain, in every map of clouds, in every quiet voice that says, "Tomorrow will be clear."